Good morning. At the time I'm recording this, it is 8 o'clock Zulu time. It is the morning where Dikeledi has overnight intensified into an intense tropical cyclone, or Category 3 equivalent on the Saffir-Simpson hurricane wind scale. And we're currently having a terminal weakening point, which will be beginning shortly as we look at this forecast here by Meteo France. We're already expecting weakening and transition into a post-tropical depression and later an extratropical depression within the next 48 hours. So, while it has enjoyed a very nice short peak, as it quickly moves and accelerates into the subtropical latitudes, it will be beginning to disintegrate. Let's take a look at the current structure on the conventional satellite here. Take a look at the satellite loop that we have here. Let's take a look at the last 24 hours that Dikeledi has enjoyed its intensification. That would have to involve me going into my settings, changing the amount of frames, and then we can look through this. Let's take a look. For now, let's enjoy the last 8 hours or so. Oh, never mind, it's just preset, right? So this is 24 hours. Enjoy the last 24 hours of imagery here. You can see very nice new vortical hot tiles wrapping, developing central dense overcast, nice eye developing, and a decent warmth. We see this very nice evolution here, very nice cirrus outflow that becomes very evident through time as the system ends up tapping into the passing upper deep layer trough. It later becomes evident at the end of the loop as well. Very nice cirrus showing expansive upper level outflow going poleward. Very nice upper divergence. We'll have a better view at this looking at the upper level atmospheric motion vectors analysis. Really, it will be a lot of upper divergence here. Again, very strong indicative barbs there. Also some equatorward outflow going that way as well. So that's very nice, very conducive environment that Dikeledi has been managing to make the most out of. But obviously, as is evident here, those westerlies are also starting to push into the system, meaning that it is becoming embedded into the westerlies, and extratropical transition is soon. It's going to be happening very soon. And overall, this peak will not be lasting much further. I want to take a look further at the current structure. So, as we see, very nice developing central dense overcast, dual vortical hot towers at times, very nice eye that becomes very clear, but it isn't very stable. We're seeing that it does change quite a bit, quite often. It does manage to hold on. I want to go to the peak frame. I think it was around 2 o'clock-ish. Yeah, so it's something like this. This is where your eye was most circular, and your central dense overcast was in its its best kind of form, really. Later down the line, as we see here, let's carry on with this loop. We see very clearly that we do see some up shear wrapping, so we'll see in a minute. We see this up shear wrapping, this persistent up shear wrapping now, that doesn't go down. It doesn't go down shear. So the down shear wrapping is really it's unable to get itself together. So it's lopsided in terms of convective mass and depth. We've seen a lot of lopsiding convection on the west side, and it's unable to get down shear, which is a definite sign that this cyclone is now weakening. It's weakening now. It's nearing the end of its peak and its peak evolution. It will now be starting to disintegrate, as I said, because of the increasing influence of the westerlies, which means increased deep layer shear as it approaches the upper trough. I should say deep layer trough, and will be a pretty clear hallmark of extratropical transitioning beginning soon. But overall, though, the banding structure that I mentioned last night is really it ended up shedding its banding structure very well. Actually, we can see that the central dense overcast overall is clearly compact. Outer banding has drastically been reduce as we see. A lot of that banding just ends up fading away. With a very nice, aesthetically pleasing, I think I'm going to pause actually this, very nice, aesthetically pleasing inflow banding, very nice spiraling band here. So that's very nice wrapping there, very nice for this kind of latitude as well, very nice feature. And we'll also be able to see this on microwave imagery. This is the latest image. This is over the past 24 hours, I think. We can see its nice core evolution, tightening up, solidifying core, closing off, becoming less bandy, and definitely in a better state, which represents its peak very nice, I think. Let's take a look at this latest image on its own, really. Again, you got this very nice inflow banding that was prevalent and is aesthetically pleasing for the most part, with a nice solid core structure. A bit thin on the north side, obviously, because those westerlies, those northwesterlies are actually starting to really get into the system. But overall, this core structure is attempting to maintain. South side, fairly nice. Overall, core structure is actually pretty good. It's still closed off. It's still holding on nicely, with some banding there. So, overall, good structure for peak. We obviously can evaluate it has peaked at a pretty strong intensity. We're looking at category 3. Could be close to category 4. Overall, very nice system we can see here. Definitely something for this latitude as well. Not something you often see in the southern hemisphere, but if systems do come out the Mozambique Channel in this kind of setup, it's certainly possible. We've seen this a few times actually. This isn't a unique case. But it's very nice nonetheless, and it was good definitely looking at the evolution of the system. Let's take a look at a loop again. It went from this very not really great looking system to a pretty decent one here. Now I want to take a look at this from a different colour scale. So this is using the Dvorak technique colour scale, and I'm going to look at it closer to the peak image. Yeah, 227. This is generally agreed on to be the peak image. We did actually have a point where we had a warm medium grey kind of eye, very temporarily, though. I think it was one frame. Yeah, I don't see subsequent frames really being with that warm of an eye, but overall, this is the peak image. It's one image. It's not representative of the intensity, I should note. That's not how the Dvorak technique works, but overall, very nice. We're looking very nice. Again, that inflow banding, wrapping in there with a very nice, not the most symmetrical central dense overcast, but certainly with a white ring present. I'm not sure if that's thick enough to classify for the white 0.5 degree width for it to be applied for the technique, but we know that there is a certain black ring which is a bit more symmetrical and definitely does fit for the technique, alongside a very nice 10 degree warm medium grey eye, closer to 11 even, with a nice kind of nice shade of warm medium, not warm medium grey, cold medium grey. I forgot the colours. Yeah, I think it is. So, very nice colours, and very nice kind of structure as well on infrared pattern. Definitely a solid Dvorak T number 5.5. I think that would also be for 6Z, at least for 6 o'clock not long ago. I think that would be the average DT or close to it. Because yeah, even this at times could actually be suitable. Or it could be a 5.0 at times, but nonetheless, I feel like some of these systems, especially that undergo trough interactions at this latitude and so on, can get estimated a little bit by the technique. You won't have such a stable structure, but you definitely do get a boost by interacting with that upper trough, as it's doing so right now. Nonetheless, very aesthetically pleasing system. Let's take a look at the visual images that we have. Should I say visible images? Sorry, that we have now as sunrise has comes. Obviously, early evolution here, while it was daytime still yesterday. That eye clearly trying to develop very banded structure, but good morning here. And yeah, we do see its kind of second part of its 12-hour peak here. It might be a bit less than that even. I don't know how long this peak will really last for, but it's definitely deteriorating now, as it obviously can't keep its central dense overcast in good shape anymore. But as you can see, very stark contrast to yesterday. You got a much better central dense overcast, much better eye. Definitely something better to look at. And once again, looking at the south side of the floater, very nice cirrus expansion going that way poleward, a good sign of very hefty upper level divergence. And you also see some cirrus going out this way, so that's the poleward outflow that I was talking about earlier as well. Overall, quite favourable environment for a nice, simple, classic jet interaction, and very good for this part of the world as well. Especially as we're nearing 30 degrees south, and not something you often see in the southern hemisphere. With this kind of latitude, overall, this kind of sets up this kind of I guess scenario is it's not something you see very often. So it's good to see. Generally, just for me, like enthusiasts myself, that just like to take a look at how stuff is happening, really how stuff evolves. It's good to watch this. These are not the latest frames. These are the latest frames. Obviously, I think we can clearly see as well how that eye is beginning to deteriorate. I think, like objectively, even I think, if we look on infrared, I think the eye temperature is quickly decreasing. No, actually, I'd be wrong. It's now in the positives. General fluctuations, and that's not really something to be surprised about. I mean, that central dense overcast. Vertical hot towers are still trying to essentially desperately wrap, but they can't. They're not appearing to wrap down shear. We're lacking we really lack expansion on the east side there. Clear fading of the cloud tops there, while we do see continued development there. It just can't wrap that way. Now, what do I say for the future? Well, I said yesterday, I said last night that this doesn't have much time left. It doesn't have any time at all, really, now. I think it's very evident this weakening now, as I said. And, you know, but even with its current, like, even without taking into account its current structure, and its current evolution now, which we're seeing, it is degrading. It's quite obvious now that this is. Ignore that. That's just the kind of data that we have for the sea surface temperature data. But this is the current position, or at least the 6C position it was, and with the continued movement of this way, and the increased influence of deep layer vertical wind shear, and subsequent influence of dry air. I'm not going to forget to mention. This is done for. Even not taking into account its current degrading structure, the environment is objectively going to worsen. The oceanic potential is going to lower quite starkly. So it's really, it's the end for Dikeledi. It's been a long journey. I think if we go back to the latest forecast, we can see it. Quite a long track. It originated in the Australian region, believe it or not, closer to Sumatra and Indonesia overall. So, very long track. It only developed around here. Obviously, that's when Mateo France had it classified as a tropical depression. And then it intensified, had a nice journey over through the top bit of Madagascar, into the Mozambique Channel, through Mozambique, into the Mozambique Channel again, and now we've got this impressive intensification phase. Really long journey, really fascinating storm, I must say. Quite a nice track. Overall, good to see. It was good to see how this evolved, how this overall played out. And good to also see model verification. Let me go through that actually. We can see here the kind of the European model solutions actually had it go, had it avoid Mozambique. Initially, this was a kind of solution that was well thought of, but I think the the ridge that was in place around here, I think it was a bit larger than that, but it was a bit stronger than anticipated, and it didn't really have it wouldn't let Dikeledi go south. But also part of that goes to Dikeledi not being as strong closer to the Comoros archipelago there. As we can see, that was only a moderate tropical storm there, and then it intensified quickly last minute, which meant it wasn't able to make that turn south quick enough before Mozambique. Nonetheless, it did manage to achieve its peak later down the line in the southern Mozambique channel. I did note that as a possibility. It did happen, it played out. It's just that some of the solutions I think I went through were a bit too bullish. But we still do have a pretty strong, intense tropical cyclone south of Madagascar. So, and speaking of verification, if we go to current storms here, this is the latest, or should I say, yeah, this is the latest updated tropical cyclone forecast track trend for the JTWC. And one thing that we should know, and one thing that we can know, is that it has trended further south as of late. We're seeing that compared to earlier forecasts, which took it further, or took it further north and further east really, without much of a dive south. It's trended south, but overall, the verification, the spread, it's not the worst. In fact, it could have been much worse really. But overall, there was good consistency within much of the guidance. There still is, obviously, because this is a kind of a high confidence setup right now, as where we are right now. We know what's going to be happening. There's good agreement with how extratropical transition is going to play out, and yeah, therefore we got good spread. It's not that bad, and it was always like that. It's been pretty much like this. There's always been good confidence within not only just the ensemble models themselves, but between a lot of the guidance, a lot of the separate guidance. So the evolving scenario of a trough interaction here. Where am I? Yeah. Oh, this is an old model, and I've completely forgot to change it. The scenario of a trough interaction here, very clear. We know what's happening as it begins to undergo it. So yeah, it's fascinating, and what's also fascinating is just the amount of outflow and upper diversions that's around as well. Big influence to the intensification process, and definitely without it we wouldn't have seen much. It's just aesthetically pleasing as well. Overall, Southern Hemisphere, I don't know what it is about it, but Southern Hemisphere outflow channels and cirrus expansion. Oh, I don't know what this is. Okay, yeah, that's because I'm already on it. Overall, cirrus expansion in the Southern Hemisphere. There's just something about it that makes these storms look pretty good. So I thought I'd mention that, just my personal opinion. You might think differently, I don't know. But yeah, I mean, that's all from me. I just wanted to go over the idea that Dikeledi has likely peaked, and it peaked at decent strength. I wanted to go over how it looks, what brought it there, and what we can really see going forward. Which is not much. It is beginning to die off. There's not really much else to say for the most part. I want to quickly just go over on the GFS the kind of how it's going to look on various plots. So this is 12Z now, this is 12 o'clock. Evident rising in pressures as this environment does deteriorate. We're seeing a more lopsided structure on the relative humidity plot there, much biased east, and eventually dry air does intrude, as usually does in this kind of situation. Eventually entrains into the whole of the circulation. That's seen just on the far end of that plot, and it does lose its tropical characteristics. Another way we could see this is probably through the vorticity and bar plot there. The trough it's after, we see very evident frontal feature there, and nearing the end of that extratropical transition, while it does struggle to catch up with the trough, it might just be able to barely finish its transition, and that's evidently seen through the kind of much more trough-like structure that's kind of evident there, very elongated as it interacts with that frontal boundary. As I said, it's good agreement between the guidance, so there's no uncertainty about how this extratropical transition really plays out, and there's not really that much significance into it. It's mainly just a tropical cyclone dying off now. And we are quite a bit out to sea now, so no land threats. Any land threats have really finished. Southern Madagascar didn't really get much, they got spared pretty nicely. Some of the guidance earlier on did want to actually take it into Southern Madagascar, but luckily that did not happen. Overall, we could have had a better kind of situation play out. We certainly, as I said, there was the European solution. If I go back to maybe like 5 days ago, this was when it was, yes, this is when it entered the channel. This was, let's go to the 9th. This was still far out, so there was obviously a lot of uncertainty and not as much confidence for something like this to play out. But just a comparison to what did actually happen, we can see it never, on this run, many days ago, a week ago, there was a confidence in some confidence in a possible Southern Madagascar kit, as seen there. But the most notable part is the fact that it didn't end up striking Mozambique on this run, and hence it had a very, let's go on to a better plot for this to be seen. Yeah, it's just standard there. As we see here, many runs ago, it not going into Mozambique had it benefit very largely off that environment. It got to not only a higher intensity, but the kind of higher intensity here, yeah, you can see 935 there. That's, I think, this is one of the strongest runs, I think, that the European model had. And we see here, it did strike Southern Madagascar on this run as well, but its peak lasted longer because it managed to stay over water longer and was able to make the most out of that environment. I'm not sure why I went to Southern Africa. And I'll show this again. Environment, very nice, that upper level anticyclone. This did verify, the anticyclonic setup, it did verify. The thing that did not verify is it staying over water, which did end up delaying its final peak. Its final long, intense peak. But I'm happy overall we did get one to kind of look at. Now, what did play out though is the fact that it did go through the channel and it did go near Europa Island there. If you can see that midget land there. There are observations for that. I will take a look into those and probably give more updates on my Twitter page, even though I don't post much right now. We'll get there. I'll post some observation data maybe. I'll definitely look into any observation data that happened there, because while it was evolving and while it was intensifying into a stronger tropical cyclone yesterday, I do think it passed nearby and we might have some good observations. So I'll take a look at those. But yeah, no, overall, I'm happy with the history of the storm. Very interesting storm to monitor and track and to take a look into. And I can't say that it's been overall bad. Models struggled to verify with the Mozambique channel section, particularly where I was talking about, but the latter bit did verify decently well, and we still got the higher intensity that was anticipated. So yeah, that's what happened with Dikeledi. It's nearing the end of its life. I don't think we'll be having more videos on it in the near future, or any more really. Um, and my main focus will probably be shifting over to activity in the Australian region, off the coast of Australia, as tropical lows 10U and 11U battle it out for who becomes the dominant system. And it could be our next intense tropical cyclone, because some of the guidance is actually quite enthusiastic on a high intensity. So we'll take a look into that later today, probably, or sometime soon, and I'll give you more updates on that. As for Dikeledi, it's dying, and this will probably be my final analysis video on it. So I thank you all for watching. I appreciate those who have came to watch. And yeah, I hope you guys have a great rest of your day. And that's all it from me. Thank you.